Welcome to the first lesson for your AP Jump Start. At this point you should have your textbook with you and in front of you and some paper to take notes and work problems on. At the end of the lesson you'll be asked to do the homework from this section. During the lesson, if at any time you'd like to pause, to take notes, or to work problems as I suggest, please do so. So here we go, section 1.1, the concept of instantaneous rate. The first thing I'd like you to do is to open your textbook to page 3. We're going to look at example 1.1 in the textbook. And if this time you will pause for just a moment to read the first two paragraphs at the top of the page that describe what the problem will be about. So page 3 in your textbook. Okay, this lesson refers to a problem relating to a door opening, and we're going to look at this as the doorway opens, and we will have the opening will be the angle D, and at a given point in time, modeled by the equation D equals 200 times 2 to the negative t, for t from 0 to 7, in other words, the first 7 seconds, we are going to look at how the angle measure of the door opening relates to time. If you'll look at the problem in the book, the first thing they do is look at time when t equals 1. And since we want the rate of time, and we are looking at angle measure in relation to time, as the door opens, modeled on the equation, if we look from second 1 to, for example, second 3, we can get an average rate of time from the slope. The slope would equal the change in angle over the change in time, which would then relate to radians or degrees, I believe they're using degrees, to degrees per second. So as each second passes and we find a slope, we will get degrees per second, or a rate of change. If you'll take a moment now to look at the textbook, you can see that as they look at t equals 1, they are comparing very short intervals of time. For example, t equals 1 to t equals 1.1, or t equals 1 to t equals 1.001. Please take a moment to look at the rest of this example and see how they are finding an approximate value for the rate of change at t equals 1. As you can see, they have taken on page 4 and looked at these average rates of change over smaller and smaller intervals until they can come to a number that is very, very close to the instantaneous rate of change. We did this at the end of pre-calculus. Some other information in this section relate to the average rate of change, or slope. This we've been doing since Algebra 1. This is the function notation. It relates directly to our original notation that we learned in Algebra 1, the change of y over the change of x, and that's called our average rate of change, or slope. Keep in mind that this is the slope of a secant line and shows an average over a period of time. We also are looking at the instantaneous rate of change of the limit, of the dependent variable is the limit of the average rate of change as c approaches x, or as x minus c approaches 0. They are referring here, again, to an equation or a model where we have a value x. We are looking for the instantaneous rate of change at x, and we have another value c. If I take the slope between these two, I get an average rate of change, But as c approaches x, as we bring these values closer and closer to each other, we can approach an instantaneous rate of change. Therefore, we call this the derivative of the dependent variable with respect to the independent variable, or y with respect to x. The derivative and the instantaneous rate of change are synonymous to each other, and again, this is taking the limit of these average rates of change, or the slope, as we bring our 2 points closer and closer together. At this time, you can stop the lesson and you can work problem set 1-1, and you're doing problem number 1. Thanks and good luck. Be sure you bring your notes and questions to Jumpstart at the beginning of the school year. Thanks.